Good afternoon, everyone, and welcome to episode 3 of the Alumni Insider, a production from the Michigan Tech Alumni Board of Directors. My name is Steve Williams, and I am an alumni board director. I'm also a proud mechanical engineering graduate from way back in 1986. So, to ensure our event runs smoothly today, I'm being joined by several of my fellow board members who will be monitoring questions. I would also like to graciously thank our alumni engagement staff who are here with us today and support everything we do as a board. So, just a few announcements before we jump in. This webinar will be recorded and posted on Michigan Tech's YouTube channel to share or rewatch if you aren't able to stay the entire time. We also have the Q&A box open throughout the webinar that you should see at the bottom of your screen. Please enter any questions here, and we'll attempt to answer as many as possible in the time we have together here today. So without further delay, let's get right into the topic we're all excited for, an overview and discussion of Michigan Tech's new aerospace engineering program, which is housed in the renamed Department of Mechanical and Aerospace Engineering. It's my pleasure to introduce today our speaker, Jason Blough, who's both the department chair and distinguished professor within the College of Mechanical and Aerospace Engineering. Jason is also a Michigan Tech alum, holding a BS and MS in mechanical engineering from Michigan Tech, as well as a PhD in mechanical engineering from the University of Cincinnati. Dr. Blough began his career at General Motors after receiving his MS, but I think quickly decided that academia was his true calling. So upon completion of his PhD, he returned to Michigan Tech as a research engineer at the KRC and became an assistant professor in 2003. This would be the beginning of a lifelong career as an instructor, researcher, advisor, and leader. Jason's primary area of expertise is noise, vibration, and harshness, or NVH, as it's commonly known, for which he is internationally recognized. He has published more than 200 papers, received over $6 million in funding as either a primary or co-principal investigator, and has taught more than 40 short courses to the industry in this field. Jason has also led Michigan Tech's SAE student chapter and its excellent motorsports teams for many years. Is an SAE fellow and was the driver behind establishing the SAE's Clean Snowmobile Challenge. Throughout his extensive career, he's received many accolades for research and teaching, such as the Blue Ribbon Coalition Scientist of the Year and the SAE Ralph R. Teeter Educational Award. Dr. Blough has been a director of graduate studies, both associate and interim chair of the department, and is currently the chair of MAE. Jason's also a Calumet native and one of the nicest guys you'll ever meet. So Michigan Tech is lucky to have him at the helm of MAE, and we are honored to have him with us today. So Jason, I'll invite you to take it away. I think we're going to start with a couple slides just to set the stage, and then we're just going to dive right into questions. So, welcome and thanks for being here today.
Thank you for the introduction, Steve. So, I'm going to share a few slides to start with, give you a little bit of background on the establishment of our aerospace program. So about a year and a half ago, I should start here, I guess. About a year and a half ago, 2 years ago, I guess at this point, I went to some of our faculty members and that have been traditionally doing aerospace type work and said, what do you guys think about starting an aerospace bachelor's degree? And the overwhelming answer I got was, it's about time. So we put together a proposal that has to go through approval process here, which includes the Senate and then the provost, and then goes to the state of Michigan, the MASU, which is the Michigan Association of State Universities, for approval. And then we're allowed to start offering the degree. So we cleared those hurdles late last fall. So we started recruiting for our first freshman class, in January is when we could first start officially talking about it. And we welcomed our first freshman class this year. So I'll give you some statistics, a little bit of background on the investment that's been made into this program, both by the department and the university as a whole. So we now offer 2 bachelor's degrees, mechanical engineering and aerospace engineering. We have a master's in mechanical engineering. We are in the process of developing a proposal for a master's in aerospace engineering. So that's coming. And then we will also change our PhD to include aerospace as part of our PhD program. Our undergraduate enrollment for fall of 2025 is 1,315 students. which consists of 76 aerospace students and 1,239 mechanical students. Our incoming freshman class this year, 341 mechanical engineers and 68 aerospace engineers. So you see a difference between the incoming freshman class of aerospace and the number of aerospace. We have some students that transferred. So students that were mechanical engineers that started last year that transferred into aerospace. And so that's why there's a discrepancy in those numbers. And there are more students that are transferring or have declared this double major, which you see right at the start of fall, we had 46 students declared double major mechanical and aerospace engineering. One of the things we did when we put this program together was we made it relatively easy for students to get that double major. It's only 17 extra credits. Most students look at that and think it's one extra semester. It's really one extra year based on scheduling, prerequisites. They're not going to be able to pull it off in one extra semester. But a lot of students don't graduate in 4 years tight anyways. They end up with co-ops and interns and miss a class here and there, drop a class. And so we figure if they're good students in 5 years, they should be able to get both degrees. And then the graduate enrollment in the department this year is 187, split almost evenly between masters and PhDs. We have 51 faculty total in the department, 39 are tenure track, 12 are instructional track. Of those, 18 of them have aerospace degrees. So, when I pulled the faculty together to propose this new degree, we had 12 faculty that were already in the department that had an aerospace background. And so it was a pretty easy lift. And it was one of the reasons they were so excited to do that. Our research expenditures for this last year were $33.4 million, which is 40% growth over our 2024 research numbers. So our enrollment is growing, our research is growing, and the number of faculty are growing. This is one slide that notes our new faculty. So we hired 8 new faculty last year. That's a bumper crop. We've never hired more than 3 or 4 in a year before that. We had a really good interview season. We had approval to hire 4 tenure track and 1 instructional track. We had such a good pool to pick from and such good interviewing that I went back to the administration and kept working on them and selling them on the success of our aerospace and what we're going to see, that I got approval to hire some extra people. The bulk of them are aerospace, or certainly support our aerospace, but not all of them. And some of the ones that aren't, one of the reasons we still made those hires was because it freed up current faculty, which have been teaching mechanical engineering courses, so they could get more involved in the aerospace. So, we did a very strategic hire. You can see there's a broad range of expertise that they come from, and all of them have education and experience at R1 universities. So the quality of this class of new faculty members is outstanding compared to what we've had in the past. I'll give you just a little bit of a highlight on what's going on with aerospace. So, I said we admitted our first freshman class. Adding aerospace engineering to our department has created a tremendous amount of excitement on campus. It's all everybody talks about on campus. The enrollment in aerospace studies, which is Air Force ROTC, is up as well. So that's been a benefit of us adding aerospace, is now they have more Air Force ROTC students that have come up here because of that. Our enrollment, so this is our freshman class, is up 30% over last year. So normally we have, we average about 300 incoming freshmen. And this year, we had 340 mechanical engineering and about 70 aerospace engineering. So we're up, 30%. One of the big concerns we had when we launched this program was how much of the current mechanical engineering class are we going to cannibalize with aerospace, and how many new students are we going to bring in, right? Because there was always the concern of, well, you're just going to have fewer mechanicals and you're going to have aeros and you're not going to have a lot more students. So, we're up over 100 students compared to last year. in the department. So, it's a big bump both in mechanical and in aerospace. This year, our incoming freshman class was 39% of the deposits in the College of Engineering, and the College of Engineering was up 17%. And our freshman class is 25% of the freshman class on campus. So we are a growing part of the university. And campus is up 4.8%. So it's not like we became a larger part because the rest of campus dropped. And then I have a note on the bottom of this slide that, aerospace in our department really started in the early 2000s with the hiring of Brad King, Greg Odegaard, and Jeff Allen. And since then, it has grown. They're all three still with us, but that's where the kind of the aerospace thrust in the department started. Investments that have been made by the university and the department. So we've had 4 floors of our building undergoing renovation. 2 large lecture halls, so 111 and 112 on the first floor have both been renovated. 3rd floor classrooms, 302 and 303 have both been renovated. And then a bunch of labs. And to support the aerospace, we're putting in, new undergraduate labs. We have an aeronautics lab, which is going to have a wind tunnel in it. We have a rocket test lab where we're going to test small rocket engines as part of one of the courses. Gas turbine test lab. So we have a small gas turbine test stand. We have a Aerospace Engineering Practice 4 course, which is Spaceflight Qualification Lab. So we're doing engineering practice courses just like we do in mechanical engineering. If you're familiar with the changes we made in that curriculum about 10 years ago, we're following that with the aerospace curriculum. We're developing a new electric propulsion lab, which has been funded by one of our very generous alumni. And that is to simulate loads on electric propulsion for drones, for ground vehicles, for marine vehicles, power sports. It's a simulation lab with hardware on a bench. We're going to have battery simulators so students can understand what happens with different battery chemistries, and they're going to have to develop the controls for the electric motors for these different applications. And the other thing we're doing is we're moving part of the mine enterprise. So the mine enterprise, Paul Van Susante advises that, and they effectively build robots to work on the surface of the moon. And they've outgrown their space, and so we're going to move them up to a new space on the 11th floor. And real quick here, I've got some of the renovations. So this is our sub-basement. If you've been around a while, on the left side of the screen, it says Wind Tunnel Lab. That used to be an engine test cell. John Johnson had an engine test cell in there for 30 plus years. On the right side of the screen, you see there's turbine engine testing and rocket engine testing. Those were also engine test cells. Those engines got moved out a few years ago, and we're repurposing those into these test cells. And then the 3 rooms in the middle are prep rooms for the labs, and then a meeting room, which we'll also use for collaboration for senior design and enterprise. So that whole front, that's the front of the building towards the Memorial Union that is being renovated there. And then this spring, we got the 11th floor of the building. So prior to this, 11th floor has been biology. With the completion of the H-STEM building, that allowed some shuffling on campus, which allowed biology to move out. We completely gutted the floor, all the way around the outside. It's completely gutted. And we have put in new labs up there. We're going to move 2 of our mechanical engineering practice labs up there. There'll be aerospace engineering practice lab up there, the mine enterprise, the new electric propulsion lab. And then the area with all the circles on it in the middle in front of the elevators is a student collaboration area where students can hang out and work together, and kind of in furniture like we have down in our lobby, only a little bit nicer. So it'll be a real nice space for the students to hang out. So that's what I had for just a brief intro on what we've been up to. And I'll stop sharing.
Well, that's fantastic. So thank you for the overview. I think we're starting to get some questions. I thought I'd just ask you one to start with. So you're, I think, joint only University of Michigan and Western in offering this degree in the state. So does this give tech some opportunities, increase enrollment, or attract additional employers to campus, do you think? Or
Absolutely. So we made a, took a long, hard look at what the aerospace programs look like, especially in the Midwest.
Mhm.
University of Michigan has one, and I have to admit, anything U of M does, they do well. So
Yeah.
they have a very good program. Western's aerospace engineering program is really geared towards pilots. So if you
Mhm.
want to be a pilot, that's really what that program is geared towards. Wisconsin-Madison has a program that's part of a minor with engineering mechanics. It's not a full-blown aerospace engineering program. Um, Minnesota Twin Cities has an aerospace engineering, and St. Cloud over by the Twin Cities also has an aerospace engineering. And then you got to go all the way down to uh, Illinois and Purdue to get aerospace. So there's not very many programs in our part of the Midwest, from sure. And we've just seen tremendous interest from high school students for the last couple of years, which is really one of the reasons we chose to do this. Is it seemed like there was really an opportunity here to grab some more students and for us to expand our research footprint. And we are getting a lot of interest from companies as well as the state of Michigan that wants to do more aerospace. So we think it's going to be a really positive move long term.
First year enrollment certainly shows that's true, right? So
Yep.
I think
Yep.
good. Looks like we got a few audience questions. Do we want to get into some of those? I think somebody in the audience is asking, why the split between traditional aircraft and rocketry?
So if you look at what ABET, who's our accreditor, supports, right? There's aeronautics and there's astronautics and there's aerospace. And aerospace allows us to span both aircraft side of things as well as the space side of things. And we're really primarily more on the space side. So where we have a choice between airplanes and rockets and satellites, we've chosen to go more of the rockets and satellite side of things. Um, but the aerodynamics course, the propulsion courses all have airplane type stuff as well. And a lot of the major differences between mechanical engineering and aerospace is really got to do with the environment that you're working in. The temperatures, the radiation that you get in space, a lot of that stuff. And so it's applicable to both. Because when you get high in the atmosphere, you get those different temperatures. Obviously, you start to get out of the atmosphere and you get into the radiation and so on. And as you get higher and higher, you lose air. And so all your heat transfer changes because you're going to lose um, convective heat transfer. You don't have any air to deal with. So there's a lot of thermal things there. And then shock and vibration is a big thing to survive takeoffs and landings. So, yeah.
We do have a question from the audience. You touched a little bit on companies that are interested in tech and recruiting students. And the question is, are there any collaborations set up with aerospace companies, funding to support programs, projects, advanced degrees, and co-op opportunities?
So we have had, between the faculty that we have that have been doing aerospace, that's about a third of the research in the department. So we're looking at, $8 to $10 million a year in research that we've already been doing in aerospace. Greg Odegaard runs a center. Well, he's on a second version of a center now that's funded primarily by NASA, along with some industry partners to develop materials for lightweight materials for deep space exploration. Many of you are, I'm sure, aware that Brad King, who's one of our faculty members, spun off and started Orbion here in Houghton, building thrusters for satellites. And that company is almost all Michigan Tech alum. If you look at their list, they hire a lot of interns and co-ops from us. And then we've had other work from Air Force Research Labs. We've had a lot of senior design projects from them, and other work from NASA. Paul von Susante's work on working on the surface of the moon and the other planets has all been almost all NASA funded, as well as some smaller space startups that he works with. So yeah, we've got a fair number of companies that already hire our graduates and our interns, our students as interns, and have been funding research for many years. So.
This is really just a comment, but I thought you'd appreciate it. So it says, "Hello, this is Shabir Parvez, ME 1977. He spent his career as a satellite GNC expert. He made a trip to Tech yet last year after 47 years and got a full tour of the aerospace facilities from Jeff Allen. Really pleased with these developments. Look forward to continued interest. I know they work for Dr. Johnson, the diesel engineering program. So that's kind of cool.
Yeah.
One of the questions is NASA involved with any of this at all? You guys have done a lot with satellite stuff, right? Or nano
So
satellites?
yeah, aerospace enterprise that builds satellites, they had one launched in 2018. They got another one they're hoping they're going to launch in 26. Those have been primarily funded by NASA and Air Force research labs. Like I said, Paul Ventusante gets a lot of funding from NASA, and we've had some NASA folks up here, both as parts of Paul's projects and some speakers that we brought in. Our students have brought in. We have a real strong AIAA chapter, which is aerospace related, and they brought in some speakers from NASA. So, and all the feedback's been enormously positive. I think a lot of the aerospace are looking forward to being able to hire more students from here. Um, we have one of our alums that was up. He works at Moog, and he said, finally, I won't have to try to justify to my upper level management that Michigan Tech graduates can work in aerospace. Because they've been hiring our graduates over the years, and he's always had to make the case of, I know they're not aerospace, but they're going to be valuable to us and they're going to be good employees. So, yeah.
Somebody's asking, structures and kinematics professor, will you have a metallic, non-metallic structure design? Asking as an aircraft structures guy.
So, to start with, we have to have the basic courses that are required for the bachelor's degree. We do have an aerospace structures course. Greg Odegaard is developing that and going to teach that. So a lot of the work he does is actually composites in his research, right? And we are starting to put together a list of graduate courses and more technical electives as we develop this and start to get students that are going to be close to graduating. And there will be more structures courses for sure. I've also been talking to the material science department about them adding a course or two on aerospace related materials.
What?
We do have a question in the chat. It says, do you have an industry advisory board set up yet? And if so, which aerospace companies are included?
So we have an industry advisory board. It's external advisory board, EAB, we call it. We're only going to have one in the department, but one of the things we've done is we have reduced the number of people that have been on that board over the last 2 years, knowing that we're going to add aerospace people. So we have somebody from MIT Lincoln Labs that does satellite work. We have the alumni from Moog, and a couple other alumni that deal with aerospace, and we're looking to add more. So we've made room on the board to add the aerospace people, and now we're in the process of identifying those people.
Well, I don't know if you're familiar with it or not. I'll send this to you later. We'll post it somewhere. It says we hire a lot of interns. Would be great to get some students here, and it's the Aerospace Partnership, Aerospace's Universities Partnership Program.
So, we'd love to offer our students up. The best way to do that at this point is to send me postings you have for interns or co-op positions or full-time. And I have a special email address, MAE opportunities. And the only thing that goes out on that to students is true opportunities for them in the hopes that they'll read them if that's all they get on that email address. So you can send it to me and I will forward it out to the students and see what kind of interest we get. But
you can approach to get at their short attention span, right? So,
well, they get so many emails that they tend not to look at all of them. So I tried to create an email address that it's worth looking at.
yes. Let's see what else here. Do you foresee partnering with other universities? So example, you've Georgia Tech for subcontracted research that Tech can perform.
So we already do some of that on the research side of things. Greg Odegaard collaborates with multiple universities in his center. Brad King has collaborated with the University of Michigan on thrusters, and that's where he got his PhD from. And we are collaborating with some other people. We've also, as we've implemented the aerospace degree, people have taken note, and so we are getting more involved. There's a group at the University of Michigan that's working with an MEDC group to put in a rocket testing center outside of Grayling. We've been pulled in to want to be a partner on that. So we are collaborating and starting collaborations with people as we move forward. So we're certainly open to any opportunities.
Okay. That's an interesting question. I think it says, will you be including rotary wing along with traditional fixed wing aero? Most universities don't give rotary wing much discussion, requiring most of our new engineers to learn it on the job.
So one of our new hires is in aeroacoustics with a specialty in drones. We'll be there. We have another faculty member who does a lot of work with drones as well. Well, we have two other faculty members who do a lot of work with drones. And I eventually, I'm sure we will have more helicopter-oriented coursework or experiences anyways. So
somebody's asking, so when they were there in the late 70s, they helped move some of the equipment into the ME, and you had a small wind tunnel in the sub-basement. Wondering if it's aero-worthy, but I think you had stated you're replacing that, right? Or you have replaced it, or?
So we have an old one around. It might be that one.
Okay.
We're waiting on our new one to be delivered. So in the meantime, we are using the old one. We've refurbished some of it. It's getting all new instrumentation right now, new acquisition system. It's not going away because it's not been crushed. It's not broken up. And we're waiting on a new one to be delivered literally any day. We ordered it about 19 months ago and we still don't have it. So we're waiting on it.
Does this help your ground vehicle engineers at all, having all this additional equipment? Can they work on some aerodynamics projects for the low speed stuff, or no?
So interestingly enough, our aerodynamics person, as an aerospace background from an engineering perspective or from an educational perspective, he spent the last 11 years running the wind tunnel at Ford. We just hired him. So certainly he has an interest in ground vehicle aerodynamics, and we're going to take advantage of that. He wants to continue to do some from a research perspective, and he's teaching the aerodynamics course. So I'm sure there'll be some ground vehicle related stuff in it.
Fantastic. I'm going to get this plug in so we can post this in the chat, but all of this labs and everything you're building sounds really expensive. So I think you'd probably appreciate it if we gave alumni the place they could donate to. So I think on your
Absolutely.
page, you've got like 4 funds set up. Is that the best place to point them to for
Yes.
donations? Okay.
Yeah, there's one actually that's mechanical and aerospace engineering labs.
Okay.
That's the best place for lab development for sure.
Okay.
So,
We'll send that link.
and we are still spending on labs. We're about $1 million in and we're still spending. So
that probably never ends, right? So
no, it really doesn't. I mean, you get everything set up and, a couple years later, you start over again, updating things. So it's a constant outflow of money to keep labs really updated and in the latest technology. So, and that's one of the things we've chosen to do. Everything we're doing, we're trying to do really top shelf, really professional. So it's not going to look like, some kid's plaything. It's actual real hardware.
Here's a question from one of our ex-board members or our life board member, Scott McBain. So he's saying there are opportunities for dual majors and minors such as aerospace and computer science. His son went to U of M and he was able to accomplish that, and it served him well. So he's just curious if somebody could do that at Tech.
So I I haven't pursued what exactly a dual degree or a minor might look like for somebody in computing. I have, but I'm sure there's options there. We have an aerospace minor, which they could take. There's a couple of lower level mechanical engineering course or aerospace engineering courses they would need to take to do that. We're also talking with electrical and computer engineering, which it also has robotics as a degree, about how their students could take advantage of it because everything in space is pretty much robotics based. So, um,
Let's see, vacuum chamber for the thrusters. Question.
so, so we still have the vacuum chambers that Brad King used to develop the thrusters that became Orbion. So Orbion still does their development work here. They have their own vacuum chambers for their testing of every thruster that they build from the commercial sense, but they do a lot of their development work in the chambers that we have here. So they're, those chambers are available for thruster development. And, Orbion funds graduate students to do that work at this point in those chambers. So there are opportunities for our students to stay involved in that thruster development.
See, people are saying out here, so there's some aircraft manufacturers fairly close to you. There's a helicopter manufacturer, Menominee, Enstrom,
Yep.
and Cirrus Aircraft in Duluth. So,
So
maybe
we have some people up from Enstrom during career fair. We gave them some tours. They're looking to establish a internship program with us, or co-op program. And we just had a speaker up from Cirrus about a month ago as part of our AAAA chapter. Gave a real nice talk and had about 80 students attend, I think. So it was real nice attendance as well. So, yep.
I think we're about out of time. I believe we've answered most of the questions. I don't know. Anything else you want to share before we wrap up here? But really appreciate you joining us today and sharing this exciting information. I really think that's going to be a great thing for students and the university and everything else. So it's just really going to be a positive impact overall.
So I'd like to add a thank you to the alumni that support us, have supported us, and are going to support us in the future. It certainly has allowed us to, put in the labs with the quality that we're putting in. And also to let everybody know that, we're open for any collaboration. If you're with a company that does aerospace stuff, certainly get a hold of us. Our students are always looking for great opportunities, and we want to support that as well as any potential research. So, feel free to reach out to me with any opportunities for the students or the department. And again, thank you for your support.
Fantastic. Well, thank you, Jason. And look for our next topic to be announced soon. If you have any feedback on how we can expand or improve these sessions as alumni, please send an email to alumni@mtu.edu. We'll put that in the chat because we'd love to hear from you. And enjoy the rest of your day. And this will be posted on Tech's YouTube channel here in the next few days if anybody missed part of it or wants to share it with their friends. So good luck with the rest of the semester, Jason, and hope everything goes well and hope that trend keeps up with more and more students that get up there. So,
Yep. Great. Thank you.
all right. Thanks.